Vanakkam. Welcome to this course on classics in neuroscience. We have been looking at neural circuits. In the past few videos, we looked at neural circuits within the spinal cord, excitatory and inhibitory circuits within the spinal cord. Then we looked at how excitation and inhibition can simultaneously happen within the retina. In this class, we will look at invertebrate systems, examples of invertebrate systems, and more importantly from this class we will look at the concept of how balanced reflexes, like rhythmic pattern generation, can happen when there is an expansion of the reflex concept that is used to explain this rhythmic pattern generation. So, in the 1950s, as we have seen previously, there was a grand work by Eccles and a lot of colleagues to improve our understanding of sensory and motor pathways for specific reflexes. This was first started, of course, by Sherrington, who went on to win the Nobel Prize for this work. Also, one of Sherrington's early students was Graham Brown. He found that there are some intrinsic mechanisms within spinal neurons wherein there was rhythmic alternating movements, rhythmic kicking of the hind legs of the rabbit that happens even in deafferented limbs. In deafferented limbs, there was rhythmic kicking that was happening. I also observed this in several other model systems. For example, the chick whose head is cut continues to walk for a few steps. This he attributed to rhythmic half centers. These are sets of neurons or neural systems that could generate rhythmic movements and that happened under balance of excitation and inhibition. Generate rhythmic movements under excitation and inhibition. This was called as half centers, rhythmic half centers. So, these half centers, they produce both isolated movements and repeated discharges. It was also found that there was an influence of descending cortical control or cerebral control. So, it is possible for this to happen in the presence of afferent input. It is possible for these movements to happen in the presence of descending cortical or cerebral inputs. It is possible for these movements to happen in the absence of these also. So, there were afferent impulses, there was cerebral control, and this rhythm was generated by these sets of neurons within the spinal cord, these groups of neurons that then were called as half centers. An example of a reflex movement where a doctor is tapping with the hammer is shown, but this is not exactly what we are speaking. This is reflexive monosynaptic reflex demonstration, but what we are speaking is rhythmic movements that are seen in specific preparations, that might be a spinal preparation, maybe a deafferented preparation, that still generate movements that resemble locomotion, locomotor like movements. It is also expanded to other species which we will discuss in future videos. Importantly, these are not command related, these must be hardwired central mechanisms. These are manifestations of hardwired, that is neural connections that happen to be there within the spinal cord, and coordination that happens between multiple segments in the spinal cord. At best, this can be intersegmental reflexes, also contralateral reflexes. These are not exactly reflex in the reflex sense of the word, that is having a delay less than 50 milliseconds, but these are hardwired central mechanisms. But when we say central, we restrict ourselves to spinal cord and interaction that happens between different segments within the spinal cord. At best, these are some sort of intersegmental contralateral type of reflexes. This kind of work was then expanded by George Coghill, who suggested that these emerge from integrated responses of developing embryo to its environment. This is seen, fetuses start moving their locomotor like movements even before birth, not so that kicking movements, that these are responses. That is, this line of work was then pursued by the Soviet researchers Nikolai Bernstein, Orlovsky and Schick, who expanded this concept in a very big way, and then this was further expanded in a great way by the Swedish scientist Grillner to various invertebrate systems, the insects, flying insects, a whole bunch of invertebrate systems also. A lot of these people have contributed to the development of this concept of half centers, that is spinal mechanisms that produce rhythmic locomotor like movements that are probably the result of intersegmental reflexes. This concept was expanded by all these scientists, the famous Schick and Orlovsky studies, the famous number of studies on insects by Grillner, insects and other invertebrates, many invertebrates by Grillner, Lundberg and many others. With this, we come to the end of this video. In this video, we looked at the concept of reflex can be expanded to include rhythmic pattern generation or rhythmic locomotor like movements that are generated by hardwired neural centers in the central nervous system, that is in the spinal cord. At best, these are intersegmental reflexes that are that have been discussed at great length by, for example, the Soviet researchers Orlovsky, Schick and Grillner and other Swedish researchers. Thank you very much for your attention.